Alright everybody, today we are going to have a demonstration of Excel and an overview of some very basic features and functions of Excel. The objectives for this episode are listed at the right. We are going to learn how to reference another cell in an equation. We're going to apply an equation to dozens or even hundreds of cells. It could even be millions. We're going to create, I forgot the E. Create a loop on a value to iterate it. Change the number of significant digits for all cells in a column. Make a plot of position versus time of a falling body. Make a plot of speed versus time of a falling body, as well as acceleration versus time of a falling body. And we're going to make and display trendline equations through those plots. So in order to simulate the data which you might acquire in an experimental setup, I'm going to generate data of the distance versus time of a falling body near Earth's surface. So we're going to start with number 3 actually. I'm going to create a loop on a value to iterate it. So we start the distance traveled at 0 meters and the time elapsed at 0. I want to just make a list that shows even intervals of time, like every tenth of a second up to maybe 10 seconds. I'm also going to move this column over here. Oh, sorry. Okay, so we have time in seconds. Initially 0. I'll get rid of this. Notice you can click on a column and say clear contents. I'm going to also show you can right click a column and insert a blank column, an empty column to the left. So what I'm going to do is say equals. You always start in a cell and say equals. And I'm going to refer to the previous cell, which is 0, and I'm going to add 0.05. 0 plus 0.05 is 0.05. Now, if I take this little box at the bottom corner, notice the cursor changes to a black plus symbol, and drag it down. So what it's done is added another 0.05 to cell B5, which is this one. And cell B4 added 0.05 to the previous cell, and so on. So we're going to iterate on the previous value. And I could just hold the mouse button down and just drag as far down as I want. Let's go down to 304. So we're 15 seconds in. So we're going to scroll back up, and there you go. Each value just adds 0.05 to the previous one. So we're iterating on the previous value and creating a loop. So now I want to come over to the distance, and I want to create an equation to all of the cells in the time column that allow me to calculate the distance the object has fallen. So once again you say equals, and we're going to type in 1/2 times the gravitational constant of acceleration, 9.81, times the time squared. So you hit that caret top and the number 2, hit enter. There you go. Here's the distance that the object has fallen in 1/20th of a second. So I'm going to show you how to apply this equation to dozens or hundreds of cells. What you don't want to do is go to the next one and try to type that in again. By the way, you can type 0.5 instead of 1/2 times 9.81 times time squared. Enter. It didn't take very long, but it sure took me about 5 or 10 seconds to type this in and explain it and hit enter. You would not want to go through each one of these and type the equation in by hand. What if you have 10 million rows? 10 million! Well, you're not going to finish in your, and even in a calendar year. So what you can do is take your cursor and hover it over that little green box at the bottom right, and you could drag it down like I showed you before. But what if the number of rows is so large it goes far off the page? You scroll and scroll and scroll. What if it just keeps going and going and going? And it's even taking you too long even just to drag it down. Well, what then do you do? Well, you could double click, just hover your mouse over that little green box. When the cursor turns to a black plus sign, double click, and it just automatically fills everything in for you. Scroll down, there you go. It goes as far down as there are numbers in the adjacent column. Because remember, we have created an equation that references cell B, or column B, which is to the left. Now we don't want to do that, so we're going to get rid of that. Okay. Lickety split. So we've also done number 1 as well. So now we want to change the number of significant digits, or sig figs, in a column. Look at this, we have 0 up here. We have 0.0122625. That is 6 significant digits. But then this one has only 4 sig figs, and everything is just inconsistent with one another. And it looks kind of bad. This doesn't look professional. So what we're going to do is highlight all of this data. And over here under General, you'll see this. You'll see a bunch of zeros next to a decimal point and a blue arrow pointing to the right, and a blue arrow pointing to the left, and this icon. Watch what happens when I click this one. See, all these numbers have decreased the number of digits displayed. If I want to go back, I hit this button. But look, now they're all uniform. They all have the same number of sig figs. So I'm going to click back, go back to the way it was originally, right here. If you were to take the top right-hand side of column C and watch as your cursor turns to a vertical bar with arrows pointing away from it, click it and drag, you'll see that I've also just changed the number of sig figs. These are 2, 3, 4. They're still inconsistent, but it got the job done. I wouldn't recommend this method. It's just good to know. If you double click, if you have it like this and you double click on that borderline between C and D, it goes back to the way it was. I can highlight the entire column, grab the green box up here, and move it down. I guess I can. Okay, so I've selected just the non-zero values, and now we're going to change the number of sig figs to just that. Like that. We're going to grab the ones that have 4 sig figs and move the decimal over 1 as well for them. And lastly, for those with 5 sig figs, and last but not least, the ones with 6 digits. We'll leave it like that. So we've done number 4. So now let's make these 3 plots and put a trend line through them. So what you do, let's fix these sig figs. Let's do like that. You can highlight the X and Y data, but only if the X appears to the left of the Y data. And with both columns highlighted, you can now go to Insert and Charts. Click the down arrow to see your list of options. You can get one with just a line and data points, just a scatter plot, or a scatter plot with lines through them. We're going to do this option. So it looks smooth, but really this is a bunch of data points so close together you can't tell. So I'm actually going to show you something. You can right click on the data and you can do select data. You can click series 1 and hit edit. So you have this big cryptic looking equation sort of thing here, but it really is just saying in sheet 1, which is your current working tab, the X values go from cell B5 to B304. I'm going to bring this down to just B25. The Y values are from C5 to C304. We want to go to C25 so that they're both to the same value. We hit OK, and now you can see the nice data points. Before the data points, there were so many of them so close together it looked like a line. But here's our nice smooth data. Then what you can do is right click a data point, add trend line, and we know that this is not a linear progression of data points. This dotted line here is a linear equation that does not model the data very well. We're going to do polynomial order 2, and you see it has a beautiful perfect fit. Then come down here and display equation and display r squared. So the r squared of 1 is what we expect from perfect data, perfect theoretical data with no uncertainty. You can come up here to the chart title and label it distance versus time. And if we want to label the axes, you can hit plus axes title. And you can say distance, units of meters. And on the x-axis we have time in seconds. Alright, so I'm going to minimize this a little bit, put it up here. Put it over here. So we want to look at the speed versus time. So we make a new column called speed with units of meters per second. We're going to start on the second row, say equals, open parentheses, grab the forward value minus the value from before, and divide that by the corresponding values of time. subtracted from one another. The forward one minus the previous one. And now I'm going to double click that, change my sig figs, and you can see it goes all the way down. There's one thing I want to mention though. We lose the last value, so we'll get rid of that. You click on a cell and then select the equation bar. It shows you what cells are active for that value. So you'll see with this value we've reached the end of the data, so that is why you cannot have a value on this very last cell. So here's what you do when you want to make a plot and the time and the x and y axes are not adjacent to one another. We have this pesky distance in the way. You can grab, like let's say just the first 20 time values, then hold Control on your keyboard and select, and it'll keep them both highlighted. You have to hold Control. That's for Windows PC. I don't know what it is for Mac, unfortunately. Then we open one of these scatter plots. Right-click the data, add Trendline, display equation, and R-squared. And as we expect, we get a nice velocity versus time. That gives you y equals 9.81 times x. X is time, so we can label these time. And seconds. And the vertical axis now is speed, meters per second. So we've done 5 and 6. And we've also already done number 8. And last but not least, let's make an acceleration column. Put our units in there. And similarly, we can select multiple non-adjacent columns of data by holding Control. Oh, but first we have to, I skipped a step. We have to first find the acceleration values by looking at the speed ahead minus the speed behind us and divide by the time at those corresponding values. And then we drag those down. You'll notice they're all the same, as they should be. And then we insert, and it looks like something went wrong. Something weird's going on. But as you notice, you can drag the x and y values that you choose to plot by dragging the selection up and down by grabbing those little boxes in the corner. I think that's a sufficient demonstration. We have a linear equation. And the equation has a value of y equals a number that's pretty much 0 plus 9.81, which is to say y equals 9.81. The acceleration is equal to 9.81 as a constant through time. I won't bother labeling these plot elements. I'm going to leave it here and see if you guys have any other questions you wish me to address in the fundamentals of Excel. Thanks for watching.